Today we are going to be discussing scientific notation. Scientific notation is a method that scientists use to convert either very large or very small numbers into something more manageable so that it's easier to write down, we don't have to write as many zeros, and it's easier to plug it into the calculator. First thing we're going to do is we're going to be converting standard notation into scientific notation. So standard notation is just what you're used to numbers looking like. So here we have 525,600, and we are going to be taking it and converting it into scientific notation. The very first thing that I'm going to do is I'm going to locate where my either visible decimal is or my invisible decimal is. Here I don't see a decimal point, so that means it's invisible, but I'm just going to go ahead and locate it and say that it should be right there. It just wasn't initially visible. Once I have my invisible/visible decimal point located, I can go ahead and move my decimal point such that I will end up with a number that is either greater than 1 or less than 10. Somewhere in between there, depending on what my leading number is. So I'm going to be moving my decimal so that 525,600 will turn into a number that is greater than 1 but less than 10. So what this looks like is I'm going to take my decimal and I'm going to move it over until when I leave it somewhere, that number would have been less than 10 or greater than 1. For my step 3, I'm going to count how many times I actually moved that decimal place to make that possible. So I moved it once, 2, 3, 4, 5. I moved it 5 times in order to achieve greater than 1 but less than 10. And I'm going to rewrite my number with my new decimal location, which is 5.256. So you can see that this 5.256, that's greater than 1, but it is less than 10. So I did move it to an appropriate location. But this doesn't maintain value. 525,600 is not anywhere close to 5.256. So I'm going to go ahead and take this information from step 3, and after I add the times 10, I'm going to use my number from step 3 as my exponent on that 10. I would add a negative sign to my exponent if I moved my decimal place to the right in order to make the number large enough to fit between these parameters, but since I moved it to the left, I'm going to leave it as positive, which means I don't actually have to add any sort of indication of whether it is positive or negative. So what my final answer is going to look like is going to be 5.256 times 10, and then my exponent again is how many times I moved my decimal point. I moved it 5 times, and I moved it to the left, so it gets to remain positive. So that's how you are going to convert standard notation into scientific notation. Now we're going to do the reverse, and we are going to be converting from scientific notation into standard notation. I'm going to use the exact same number that I just found here, and I'm going to make sure that we did this correctly. So I have 5.256 times 10 to the 5th as my scientific notation number, and I'm going to convert it into standard notation, and we're going to check our work and make sure that it's actually correct. My very first step is going to be to move my decimal point the same number of places as my exponent. So my exponent is 5, so I'm going to move my decimal 5 times. A negative exponent would mean that I would move the decimal place to the left, and a positive exponent would mean that I would move it to the right. This is a positive exponent, so that means I'm going to be moving the decimal place to the right 5 times. So I have my initial number, 5.256, and I have gone ahead and drawn moving it over 5 times. You'll notice these empty baskets, and right now they're going to remain empty. And we're just making sure that we know where our new decimal place is, and keeping count. Step 2, we are going to be adding zeros to any of those empty spaces. That way we can maintain value. So I had 1, 2 empty spaces, which means I should have 1, 2 zeros on the end of my number. So I went ahead and I drew that in. And then I went ahead and cleaned up my number so that it looked pretty. I removed my decimal place movement bumps and I recolored my zeros. So my final answer was 525,600, which was my initial input, which means that we both converted it into scientific notation correctly and we converted it out of scientific notation correctly.